Okay, guys, we are going to pick up where we left off. Sorry for the quick ending on the last video. The time cut out. So we successfully canceled our minutes, and the units that we're left with are feet per second. So what we need to do now is grab the calculator. We need to do 65 times 5,280 times 1 times 1, and then divide it by 3,600 is what the denominator is. And I ended up with 95.3 repeating feet per second. All right. Next up, we're going to look at accuracy. All right, so accuracy is talking about how exact your answer is, how accurate your answer is, and it's all based on rounding, estimating, approximating. This is one of the reasons why if you use the pi button on a calculator, you'll get a different answer than if you use 3.14. So accuracy is talking about how exact your answer is. There is a difference between approximating and estimating. When we approximate, that means that we round our answer at the end. So when we do like estimating square roots, we say that this is approximately. That's because we're estimating at the end, or rounding at the end. When we estimate, that's when we start at the beginning of the problem and we change the numbers we're dealing with originally so it affects our answer at the end. All right, number 23. Determine whether the situation requires exact, approximate, or estimated answer. Recipe calls for 4 cups of sugar. Whenever you're cooking, this is a situation where you want an exact answer, or sorry, an exact measurement. Going away from 4 cups of sugar is either going to make the recipe be too sweet or the recipe not sweet enough. So whenever we're dealing with a mixture type of situation, especially in science, you want to be exact. Number 24, same question. Total capacity of an elevator is 2,000 pounds. When you look at that, you probably look around in the elevator and you are going to estimate each person's weight. You're not going to ask each person how much exactly they weigh and then estimate your answer. So this is a situation where an estimate is acceptable. So you would look around and say, well, this person is about 100 pounds, or this person is about 200 pounds. All right, at this point, I want to go to the back of your review guide here and start in linear models. I'm going to have to make a third video, so I want to keep all the radicals together. So this is on the back, linear models. First thing, linear, that means y equals mx plus b. Remember that m is the slope, which tells you the amount of increase or decrease. And the b is the y-intercept, which is the initial value or your starting point. Number 19, Lucy gets paid $150 weekly plus $10 for every computer she sells. Write an expression that represents her income. So I'm going to say that Lucy's pay that she receives depends on the number of computers that she sells. So I'm going to use function notation here. So this is telling me that Lucy's pay depends on how many computers she sells. And from the information, we know that she is going to get initially $150. So that's our starting point. And what's going to change is that she will increase $10 every time she sells a computer. So this equation right here shows me that the pay Lucy receives depends on the number of computers she sells. She'll get $10 for every computer plus the $150 she gets from the beginning. All right, number 20, Andy wants to mail a package. It's going to cost $4.99 plus 30 cents for every ounce. So write an equation that represents the total cost of shipping. So I'm going to say that the cost of shipping is going to depend on the weight of the package. I don't want to use O for ounce because it looks too much like a 0. So the cost is going to depend on how much the package weighs. We know that he has to pay $4.99 regardless of how much his package weighs. But 30 cents for every ounce. So this equation now can be read that the cost of mailing the package is going to depend on the weight, and that it's going to be 30 cents for every ounce that the package weighs, plus $4.99, which could just be miscellaneous charges. Wherever he's mailing it, could be the cost of the box, the packaging. All right, next one. Last one on this page, this video, is consecutive integers. So we did these early in the year. So consecutive means one right after another. So if x is the first number, then the following number would be x plus 1. And then the number after that, or the third number, would be x plus 2, and so on. Whenever we do even and odd, we have to use x plus 2 and x plus 4, because remember that even numbers, as well as odd numbers, to be consecutive, they actually skip one. All right, number 21. 3 consecutive integers add up to 153. Find the 3 integers. All right, so we're going to use the basic setup. They're consecutive integers. So x is going to represent our first number, x plus 1 would be the second, and x plus 2 would be the third. And then if we add these up, we get 3x plus 3, and we're told that that should equal 153. So now to solve, we'd subtract 3 from both sides, divide both sides by 3, so x is 50. So our first number, would be 50, thinking ahead. The next one is 51, the third one is 52, and if you run a quick check, that adds up to 153. All right, number 22, 3 odd numbers add up to 381. So we're dealing with odd integers. So if x is our first odd number, then x plus 2 would be the next odd number, and x plus 4 would be the odd number after that. Right? Again, they're adding up. So 3x plus 6, and it should equal 381. So subtract 6 to solve. We get 375. Divide both sides by 3, so x is 125. Which is good because we were supposed to get an odd number. So 125 is the first odd number. The next one would be 127. And the next one would be 129. And if we add those up, we get a total of 381.